Alright, today starting with lesson 3.1, we're going to be going over the following things. For quadratic functions, we have the opening, whether it's up or down. We'll find the vertex, we'll find the axis of symmetry, we'll list any intercepts x and y, we'll write the domain and range for the function, and then we'll be graphing the function. Now, we're also going to look at some graphs, we'll write the equations for the graph, and then we'll look at finding maximum revenue, which is basically the vertex for your function. Alright, so to start off, here we have our first example. We got x squared plus 2x plus 1. So recall that with quadratics, it's either a U-shape or an upside down U-shape. The U-shape, we call it opening up, because the opening is on the top towards the up, and this one is opening down because it's upside down, is open is down at the bottom. So in this case where we got x squared, this is a positive function, which means this one is going to be opening up. If it was a negative function, it would be opening down. To find the vertex, recall that the vertex, that's the top peak or the bottom peak for your function, which in our case is going to be the bottom part of our function, this little spot down here, because we've got opening up. To find the vertex, we will use an equation. It's called negative b over 2a. That will give us the x coordinate. And we'll plug that into our function to get the y coordinate for our vertex. So recall that a, b, and c. A is always the number with the x squared, b is always the number with x, and c is always the constant when we're talking about quadratics. So negative b, in this case that would be negative 2, divided by 2 times a, and a in this case is 1. So that means our x coordinate for the vertex is negative 1. So now we're going to take that negative 1 and plug it back into our function, and that will give us the y coordinate for our vertex. So we got negative 1 squared plus negative 2 times 1, so that would be negative 2. And then plus 1, so that would give us 0, which means the vertex for this function is negative 1 comma 0. Now the axis of symmetry, which is very easy. We already had to find the axis of symmetry when finding the vertex. It's just this x coordinate, or in other words, x equals the negative b over 2a. So our axis of symmetry is x equals negative 1. So that would be a line going up and down like this, which means it's the reflection point for our parabola, which is this U shape. So our would be right down the middle right here. Okay. Now we're going to find the x and y intercepts for this same function. The y-intercept is really easy to find. You plug in zeros for all of the x's. So in this case you would get 1. The x-intercepts, those are a lot more difficult to figure out because we have to factor this equation. So I'll give a quick reminder of how to factor for most cases. So if we're going to take x squared plus 2x plus 1, we want to make that equal to 0 so that we can find the x's. Alright, so remember you need to factor this. In most cases you're going to say, well, I need two numbers that multiply to 1 and that will add to this middle number. This one's really easy to factor. We've got an x plus 1 and an x plus 1. Because 1 times 1 is 1, and 1 plus 1 is 2. Now if we set those equal to 0, to make this part equal to 0, the x would have to be a negative 1. It also works for this part. X would also have to be negative 1. So our x-intercept, we have negative 1 comma 0. Now what's the domain of our function? Anytime we have a parabola, whether it be pointed up or pointed down, Our domain will always be all real because we can plug in any number we want. We can plug in any x we want, whether it be negative or positive, we'll still get an answer for it. So our domain is always all real. A range, on the other hand, a range depends on what's happening with our function. So our range will always be from the vertex, and if the parabola is pointing up or opening is up, it's going to be greater than or equal to. And if our parabola is pointing down or opening down, our range will be less than or equal to. And we're looking for the coordinate on the vertex, the y-coordinate, which was 0. Right? So in this case, because we're going up, our y would be greater than or equal to 0 for our range. Now to put it all together. We said the vertex was at -1, 0. We said that the y-intercept was at 1, so 0, 1. We had a line of symmetry going right down where x is -1. So with that line of symmetry, it means that this point here would reflect over to here. Now there's the beginning of our parabola. Now sometimes it won't give you enough to know where it reflects or whether it's up or down. So you might have to just pick a couple of numbers to plug in. Say for example, let's plug in a 1. Because 1 into this function is really quite easy. That would be 1 squared plus 2 times 1 plus 1. So that would give us 4. So if we plugged in a 1, we should get an answer of 4. We can then reflect it across the line, and you can see that there is the shape of our parabola. So you could just draw your lines going through those dots. There's what our parabola would look like.